Hey, I'm gonna try and keep this quick. In about 34 hours, I have my discrete structures for CS final. Excited because after that I have one more final, and then from there I'm going home. Actually, no, that's not true. From there, I have my student government board, the retreat, for 3 days, and then I'm going home. But boom, shocking news, not shocking news, 'cause I already said it. But I get my new laptop on my last final day, so that's gonna be exciting. Um, but yeah, discrete structures. Hard class in my opinion. Not hard in terms content wise. It's more like one of those classes where you have to think in a certain way. I think that's like the appeal of it. So definitely, I think the content, like for intro to matrices and linear algebra, for reference, that class was more challenging in the content. Like you have to understand the rules. You have to know how to manipulate stuff. You have to like know. You have to be very careful like with your additions, your multiplications, like because there was a lot of that going on at once. Whereas this class is less of that. It's more so just like you have to think in a certain style of law. Like well, as, gosh, as you approach the problems, you have to have a certain framework of logic to approach them, which isn't like too hard to adopt, but like it takes some time to start seeing like in Oppenheimer, if you've watched that, like when it's not about if you can read sheet music, it's about if you can hear music, something like that. And it's like that's how you start to notice it. I think that's really just comes from practicing. Um, but yeah, I don't think again same thing I said in the post game interview for I think the intro to matrices and linear algebra exam, but I think I didn't study as much as I should have over this semester, and that's really coming back at me right now. So then that's what I'm dealing with. But I do think it's going well. I've covered a lot of the foundations for the class. The only topic I am yet to really go into that is I think is going to be on the exam. I'll get to that in a second. Is the structure induction. So I'm excited to cover it. When I say I think it's going to be on the exam, so the way it's working apparently, like we're given a sample of the final exam, right? And that exam had like maybe 6, 7 questions, each of a different topic. But the thing is, that not like the exam that he's giving us isn't like not all the topics that are on the sample are going to be on the main final, right? And I think I don't like that personally because I don't know what to like. I feel like I have to study for everything, and my issue with that is like if I find a particular topic that like, I'm really struggling on, right? Dedicate like a lot of time on it, then it could be the case where I come to the exam and that's not going to be on the exam, and then now I just waste like that amount of time. I guess there is an argument to be said like, oh, at least you learned the thing, but I do think like when it comes to like studying periods like this, you're less likely to retain that information for a long time. But who knows? Um, Excited though, excited. I think it's gonna be fun. I do like the content. That's one thing I've been saying. I've been like saying this every time and every time. But I really like applications, interviews, exams, assessments, all that. Because like there's so much review that goes into it. Like once you do that review, like you learn, like you get that, you kind of build up that love for the topic or wherever you're dealing with. I think that's really exciting. So with this class, like it's actually like the class is fun, like when you go to lecture, but like during the review, I'm starting to understand stuff more. Like, oh dang, it's actually pretty fun. Like you get excited about some theorems as well. Like sometimes, like the professor, he gets excited about the theorems. Like, oh dang, like I guess it's exciting to him. Like as I'm doing it now, I'm like dang, like that makes it so much more efficient. So I know, so far my favorite theorem of the whole class is Fermat's-Little theorem. Fermat's-Little theorem, if I'm saying this correctly, it's essentially let's say you have to get like the modulus of some big number, right? Modulus is basically like that you once you divide the number, what's the remainder of it? So like if you have 4 divided by 2, the modulus will be 0 because 4 divides 2 and there's no remainder. But if you have 5 divided 2, then the modulus would be 1 because 5 goes into 2 times, and then that's when it gets to 4, and then there's a 1 remainder. So the modulus is 1. So let's say you have something like damn, I got my example here. But let's say you have 5. Let's say you have 5 to the power of like some big number like 147. Yeah, let's do 147. 5 and you're divided by 13. Now, Fermat's-Little theorem, as far as I understand it, is basically if the number you're dividing by, right? If the divisor is a prime number, then gosh, I really recite my tools here. If the number is a if the divisor is a prime number and the power is one less than that prime number, then was it your modulus is just going to be one, right? So if what's a good example here? Ooh, I'm just gonna do one right off here because why not? So you have 5 to the power of 147, and that's the divisor is 13. So one less than 13 is 12. So 5 to the power of 12 divided by 13, the remainder is going to be wrong. One. Am I correct there? Yeah, the modulus is going to be wrong. One. So 5 to the power of 12 mod 13, that gives us 1. Now, what's interesting is that we have the number 5 to the power of 147. So where arithmetic modulus works is that it's basically like similar to arithmetic. So now what we can do with the number 147, or I guess 5 to the power of 147, is that we can break that up into 5. Because when you can break it up into 5 to the power of 3 times 5 to the power of 144. I'll get to why we do that in a second. But 5 to times 5 to the power of 3 times 5 to the power of 144. Essentially, with exponents, or I guess with powers, once you multiply like the base numbers, you just add the exponents. I think that's how it works. That's how it works. So like 5 to the power of 3 times 5 to the power of 144 gives us 5 to the power of 147, and that was our original number. Now this is really cool because what happens now is that we're trying to find out what the modulus, the remainder, would be if we divide 5 to the power of 147 by 13. Now what's cool is that now, since we know that Fermat's little theorem states that if the power is one less than the uh, the divisor, right, and the divisor is prime, then the modulus is going to be 1, right? And what's interesting is that applies to multiples of that exponent. So in our case, 5 to the power of 12 mod 13 equals 1, but 5 to the power of any multiple of 12 is going to equal, mod 13 is going to equal 1. And a multiple of 12 in our case would be 144. So then 5 to the power of 144 mod 13 equals 1. So since it's an arithmetic modulus, I really wish I showed this on the screen. But in arithmetic modulus, 5 to the power of 3 mod 13, 5 to the power of 3 times 5 to the power of 144, in brackets mod 13, the same thing as doing 5 to the power of 3 mod 13 times 5 to the power of 3, 5 to the power of 144 mod 13. Same arithmetic rules we have for basic math. And since we know 5 to the power of 144 mod 13 equals 1, then we just need to find out 5 to the power of 3 mod 13. And 5 to the power of 3 is 125, 25. 5 squared is 25, times that by 5, 125. So now what we have to do is figure out the modulus of that. And since 13 goes, quick math here, 13 times 10 is 130. Subtract that by 13. 130, I think that's 117. Yeah, 117. 117 is 8 less than 125, so our modulus will be 8. And that's Fermat's little theorem. I explained in the most verbose, lengthy way I could, but that's the idea, and it's really helpful. I don't think it's gonna be on the exam that much, but I think I really like it. It's just a fun theorem that I can explain. I think that's probably what I like about it. That I have a good grasp on it, I think. But yeah, exam, 34 hours, I believe. So I'm excited about that. I think what I'm going to do in the next couple of hours, I'm going to try and stay up to like 5 a.m. or so, and just really finish structure induction and just rack up those experience points. I think that's really just going to be the key to the exam. I don't think it's a matter of anything else really. I think that's the best I can do. I will say before to this video, I think I touched on how I just need to get a B for this exam, right? I just need to get a B to get the grade I want. But I think that was kind of a weak mentality to even approach the exam with. And after doing some studying, my goal is ultimately for an A, because I really want to go through the exam and be like, dang, I got an A. I feel like the content is fun. I think it's really fun. Sometimes it's confusing, but like there's nothing here that I dislike personally. I think that's a weird thing to say when you have stuff like when you're working with like math and logic, but like it's a fun thing to do when you understand what's going on. personally, I think my favorite topics are mathematical induction and the modular stuff, just because I think I have a good idea on what's going on there. But yeah, I will study. I will work on that. I had dinner, which was just some ramen. I've also learned the key to making ramen. I think it's really cool. To make ramen, what I used to do was I put a bunch of water, boil that, then put the ramen in. But that's not the strat. The strat really is to put as little water as you can, and then put like boil that, and then put the ramen in. So what I found out was that the putting a lot of water was making my ramen noodles soggy. I kind of like them really like I like them more chunky and just like hard in general. So just do that, and then since it's less water and the more of the taste packets or whatever you call them actually goes into the noodles, I think, and it's just tastier in general. So I just been having that for dinner like every day. I remember like today at 5 a.m. I made ramen noodles. I think that was one of my favorite college experiences so far. But yeah, besides that, I have nothing else to say. So have a great day.